I am Dr. Gaurav Saxena, Associate Professor in EC Department. Today I will discuss the another application of operational amplifier which has been asked in the AKTU examination, which one is unity follower. So what is the meaning of unity follower? So we design a unity follower by using the operational amplifier. This is the first task. First we introduce what is the meaning of unity and follower. So what is the meaning of unity? Unity is the one and follower the what is the meaning is which follow the input voltage, follows the input voltage. So that means the output should be the having gain is 1 and which follow the input voltage. That means such voltage, output voltage having a this relationship V naught is equal to Vi. So such operation amplifier is called the unity amplifier. So how we introduce a unity amplifier and how we design a unity amplifier? So we design a unity amplifier by using the non-inverting amplifier. How? Kaise? You have to just see that. First, we introduce the input voltage as the non-inverting terminal, and we shorted the. This is the feedback resistance, and this is the input resistance. So input resistance should be. This one is grounded. Ri should be infinity in this case, and RF should be 0 ohm in this case. So what is the condition for designing a unity follower? We know that. What is the output voltage for non-inverting amplifier? Which one is 1 plus RF upon Ri of Vi. This is the V naught is equal to RF upon Ri, 1 plus RF upon Ri into Vi. If feedback resistance should be 0 ohm, that means the V naught is equal to the 1 plus 0 into Vi. That means V naught is equal to Vi. So by using the feedback resistance should be shorted. So that means that this is short circuited. So the gain of that such amplifier should be 1, which follow the input. That means the V naught is equal to Vi. So such circuit is called the op-amp works as a unity follower. So first question I have to be asked here, ki what is the application of unity follower? Because the output should be the same at the input voltage. So what is the application of unity follower? Application of the unity follower is the first very important application. This is impedance matching. Impedance matching. Impedance matching. What is the meaning of impedance matching? High impedance line. High impedance line to be matched with low impedance line. So we use this unity follower because we know that for a op-amp, the input impedance should be high. So by using the maximum power transfer theorem, such I just given is one example, having any amplifier having a gain is 2 mega ohm, which is connected to the lead having a impedance of 75 ohm. So if we directly insert this cable to the amplifier output, so most of the power is to be reflected back because of the impedance mismatching, because the amplifier output stage having impedance is Z0 is equal to 2 mega ohm, but the cable having a impedance 75 ohm. So the because of the impedance in variation, so the most of the power is to be reflected back to the amplifier. So such circuit is called the attenuator circuit because no power is to be transmitted to the amplifier to the any speaker. So how we provide a impedance matching between the amplifier circuit to the speaker? So we have to be introduce a such op-amp having a input impedance should be high, which is matched at the 2 mega ohm. So they produce a maximum power at the input end, and because the output impedance of such op-amp having a unity follower is very low in the range of 75 ohms, so this should be matched with the this lead. So that means output and input matchings to be matched, and the maximum power is to be transferred to the amplifier, to the this speaker or this lead. So that means this op-amp works as a impedance matcher circuit. So all the unity follower or buffer amplifier, this is also called a buffer amplifier, which produce a impedance matching work between the high impedance line to the low impedance line. Another application of op-amp is integrator and differentiator. Integrator and differentiator. So what is the meaning of integrator and differentiator? If we want a output of integral of input voltage, that means if we want V0 is proportional to the integral of Vi, so we can say the such circuit is called the integrator. And if output voltage is to be proportional to the differentiation of input voltage, so we can say such circuit is called the differentiator circuit. So first we introduce a integrator circuit, then we introduce a differentiator circuit. How we design an integrator? This is a Ri, input impedance. This is the output capacitance. So we can say this is a CF having a capacitance CF. This is the input voltage and this is the output voltage. This is the output voltage. This is a IC 741 IC, and this is the plus 15 volt biasing, minus 15 volt. So how we establish a relation between the output to the input voltage if your op-amp works as an integrator? कैसे करेंगे? Same, the bias current should be, op-amp should be IL1, the bias current should be 0. Then by using the virtual ground condition, potential at node 2, which one is equal to the potential at node 1, that means this is 0 volt and this is also a 0 volt, and this is I1, this is I2. So the current flowing in that particular input resistance, which one is I1, and the current flowing in the capacitance circuit is I2. So how we calculate it? So just apply a KCL at node 1. KCL at node 1, that means the I1 is equal to the I2. So how we calculate the I1? I1, we have to be taking the potential difference upon resistance, which one is Vi minus 0 upon Ri. So I2 is the current flow in the capacitance circuit. So how we calculate? We know that Q is equal to CV, Q is equal to IT, C into V, I is equal to current in capacitance, which one is equal to C dV by dt. So that means I2 in the this feedback path, which one is equal to C is the capacitance. So that we assume the capacitance is CF d by dt. What is the potential difference? 0 minus V0. So we solve is V0 Vi upon Ri CF minus dV0 upon dt. So this one is Vi upon minus Vi upon Ri into CF dV0 by dt. So we want a V0 is the function of Vi. So integrate both sides with respect to the t, plus C is the arbitrary constant. So if the capacitor is initially discharged, totally discharged, so the capacitance, this arbitrary constant should be 0, and this one is minus 1 upon Ri CF integral Vi dt, which one is equal to V0. So this is the relation between the output to the input. If your op-amp works as an integrator circuit, V0 is equal to minus 1 upon Ri into CF integral Vi dt. Second is, what is the differentiator circuit? in the differentiator circuit, that means if the output should be the proportional to the difference of differentiation of input voltage, how we can design it. This is minus plus IC 741. This is the capacitance having CI, and this is the resistance RF. This is the V naught. This is also this is VI. So we solve this. This is the node 1, this is node 2. So node 1 voltage is 0. So which one is equal to the node 2 by according to the virtual ground condition? If the current flow in that particular circuit is I1, this one is I2. So that means that if we apply a KCL at node 1, so that means the I1 is equal to I2 if all the bias current should be 0. That means what is the I? I is equal to, we know that C dV by dt. So Ci is the capacitance and d by dt. What is the potential difference? Vi minus 0. I2, what is the I2? I2 is the potential difference 0 minus V naught upon RF. So we easily calculate V naught is equal to minus RF into Ci dVi by dt. So this is the output relation between the input relation, where your output is to be totally depend upon the differentiation of input signal having a gain of RF into Ci. So such circuit is called a differentiator circuit, or we can say op-amp works as a differentiator amplifier. Third one is op-amp as an adder circuit. What is the meaning of adder circuit? If we apply a n number of inputs, so if we want the output is to be the sum of all the inputs voltages, so such circuit is called the adder circuit. So adder circuit is to be performed by two types, which one is inverting adder and non-inverting adder. So first we introduce inverting adder. That means that if output is to be invert of that particular input, that means the output having a 180-degree out of phase of inputs, such circuit is called the inverting adder circuit. So in that particular circuit, V1, this is the R1, and another voltage we have to be apply here, V2, R2, and up to that dash Vn, Rn, and this is ground terminal, and this is connected to the output terminal by using the feedback resistance. Suppose the I1 current flowing here and I2 current flowing here and IN current flowing here. So what is the output voltage? So we establish a relation between the output to the input voltages. So in this case, we already discussed, this is terminal 2, this is terminal 1, and terminal 2 is equal to the terminal 1, which one is 0 volt. By using the virtual ground condition for ideal op-amp, we apply a superposition theorem at the input terminal. That means that at a time one voltage to be active and other voltage to be vanishes. So first we apply a V1 voltage and all the voltage to be vanishes, then the V1 R1, and this is a simple inverting amplifier. So if I can say this is a VO1 voltage, so what is the output voltage VO1? If V2, V3 and Vn voltages are vanishes, so that one, which one is equal to minus Rf upon R1 into V1. This is equation number 1. And such that if we introduce a V2 voltage and all the voltage to be vanishes, so the output is minus Rf upon R2 V2, such that if we introduce a n number of voltage, NH voltage we have to be introduced, and all the voltage to be vanishes. So the output voltage is VON. That one, this one is VON RN, and this one is VN. So what is the output voltage? Algebraic sum of all the individual voltages. So total output voltage, which one is equal to minus RF upon R1 V1 plus minus RF upon R2 V2 plus minus RF upon up to that dash minus RF upon Rn Vn. If if condition is that R1, R2 and Rn all are same, then V0 is equal to, and which one is equal to R. So the output voltage we have to put here, V0 is equal to minus RF upon R, V1 plus V2 plus up to that dash Vn. So this is the relation between the output and input voltages. So we see that the output is proportional to the sum of all the individual voltages. So such circuit is called the inverting adder circuit, because the minus sign is here. So minus sign indicate the output is to be a 180 degree out of phase of the input voltages, and the gain is RF upon R, where R is the this individual voltage and which one is equal to R. So that means the output is equal to the V1 plus V2 plus up to that dash Vn, having a gain is minus RF upon R. And the non-inverting adder circuit, what is the non-inverting adder circuit? That means if we want a no phase shift between the input and output voltages, so we introduce a non-inverting adder circuit. So that means if we apply all the input voltage at the non-inverting terminal, having a voltage V2 up to that dash Vn, and we apply R. So, and this is the Ri, and this is Rf. So what is the output voltage? So we easily calculate, because this is a bias current should be 0, because the ideal one, this is op-amp should be ideal one. So we easily calculate V0 is equal to 1 plus Rf upon Ri, V1 upon R1 plus V2 upon R2 up to that dash Vn upon Rn. This is the output voltage. We have to be just prove that 1 upon R2 plus 1 upon R2 plus up to that dash 1 upon Rn. How we solve this question? Suppose this is I1, this is I2, and this is up to that dash In. So we find this potential V. Suppose having a node 1, the potential is B, so this voltage to be appear here. So I1, I2, I up to the In should be 0. So that means we apply a KCL at node 1, I1 plus I2 up to that dash In, which one is equal to 0. So what is the meaning of I1? I1 is potential difference. What is the potential difference? V1 minus V upon R plus V2 minus V upon R plus up to that dash Vn minus V upon R, which is equal to 0. So we solve this question. So we IA and IB current flow in that particular circuit. So we apply a KCL at node 2. So what is the KCL at node 2? IA is equal to IB. IA is equal to IB. What is the meaning of this? IA is equal to 0 minus V upon Ri, which is equal to V minus V0 upon Rf. So V0 is equal to 1 plus Rf upon Ri into V. We put the value of V in terms of this here, and the V, if we solve this question, so this one is V1 upon R plus V2 upon R up to dash Bn upon R upon 1 upon R plus 1 upon R plus 1 up to dash 1 upon R. So we put this value here. So we easily calculate the output voltage for non-inverting.